Okay, so now we are ready to look at vector addition using scalar components. This is the method we will use to actually carry out calculations. This method comprises three main steps. First, we have to resolve all the vectors we have into their corresponding scalar components. So this may be one vector and we find the scalar components. We could have another vector like this and we find the scalar components. So we're going to end up with a sequence of x scalar components and y scalar components. What we then do is simply add up all the corresponding x scalar components and y scalar components, leaving us with one resultant x scalar component and one resultant y scalar component. The final step is to take those two scalar components and determine the magnitude and direction of the resulting vector. So let's see how we can apply this to the addition of these three vectors. Our three vectors are vector A, which has a magnitude of 9.8 and is at 54 degrees. Remember, these angles are measured counterclockwise from the positive x direction. So that's 54. B is 9.2 and at 22 degrees from the positive x direction. And C has a magnitude of 4.2 and is at 30 degrees from the positive x direction. We can find the components of these vectors without redrawing our diagram. This diagram is good enough. However, just to make it clear, I will redraw the vectors tip to tail so you can see the connection between that method and this one. So as you can see over here, the components are all determined, added up, and this is the resultant vector, which is not shown yet. By the way, these toggles allow me to see the vectors or not. So here we see the three vectors drawn tip to tail. Remember, this redrawing is not really necessary. I'm only doing it because I think it will make the explanation a bit clearer to you. We can see the original layout of the vectors using this toggle. So instead of having them here, I'm placing them tip to tail over here, just to make this explanation a bit clearer. But we won't need these here again, so I'll just toggle them off. When we're going to add vectors, what we need to do is find the components. So first, let's look at the vector components. So for this vector, the vector components are this one and this one. The corresponding scalar components are AX is 5.76 and AY is 7.93. So how we calculate these was shown in a previous video. So look back at that video if you need a refresher. So likewise, the vector components for this vector are these two. The corresponding scalar components are BX is 8.53 and BY is 3.45. And for this, the corresponding scalar components will be Cx is 3.64. Notice these are the vector components and these are the scalar components. These are vectors, these are just numbers, which can be negative. So in this case, they're all positive. And that again is just because I think it becomes easier to work just with positive numbers. We'll look at an example with negative numbers shortly. So Cx is 3.64 and Cy is 2.1. So what do we do next? We simply add up these scalar components. So all the x's, when we add them up, we get 17.93. All the y's, when we add them up, we get 13.47. So then with that, now we need to take these two scalar components and find the magnitude of the vector and the direction. Again, so how we do that was shown in a previous video. So let's look at these components here. So this Rx is equal to Ax plus, by the way, I have a little mistake here. This should be like this. So I hope that didn't throw you off. So this is x and that's y. So Rx is equal to this vector plus this vector plus this vector, and Ry is equal to this vector plus this vector plus this one that we can't see anymore. So remember, it was right here. So using Pythagoras, we can get then the magnitude of this vector, which is the resultant. So this vector is the sum of these three vectors. So notice that the method of using scalar components fits in perfectly with the method of the tip-to-tail method. So how do we get the magnitude of this? Applying Pythagoras theorem, and then we can use some trigonometry to get this angle here, which turns out to be 36.93 degrees. Okay, so let's look at another example. Here we have these three vectors to add up. This vector has a magnitude of 6.8 and is at 130 from the positive x direction, so that's from here 130 degrees. Vector B has a magnitude of 11 and is at 22 degrees, and vector C is 7.8, has a magnitude of 7.8 and is at 240 all the way around here. Like I said previously, we could work with these vectors just as they are. But just for this video, I'm going to draw these vectors tip to tail. So here they are. That's vector B, and now that's vector C. Maybe you want to compare that with the original disposition of the vectors. Notice this vector is parallel to this one, only that the tail touches the tip of vector A. This vector is the same as this one, only that its tail touches the tip of vector B. What we now need to do is find the components. So we look for the components of A. Notice now this will have a negative scalar component. Vector B, both of these scalar components will be positive. And vector C, this will be a negative scalar component, and this will be a negative scalar component also. So we can see that here. When we add up the x scalar components, we're going to get a minus 4.37, a plus 10.2, and a minus 3.9, giving us 1.93. When we add up the y components, we get 5.21 positive, notice, 4.12 positive, but the scalar component for this vector component is negative, minus 6.75. When we add them up, we get 2.57. So again, we get two positive numbers here. That doesn't have to be the case all the time. You could get positive numbers, negative numbers, in any of four combinations. Positive, 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 negative, negative, positive, negative, negative. So let's see the corresponding vector components for these two scalars. Notice? And of course, we can apply Pythagoras and get the magnitude of the resultant, which happens to be 3.22. And this angle here is 53.17. So I hope you get the understanding. What I'm focusing here is more the what you need to do than the how. The how is important. By that I mean how you actually find these scalar components, and we've looked at that in previous videos. What I want you to see here is how we do vector addition from a high level point of view. It's a very simple process. You don't need to draw this complicated diagram. You just need to know how to find these scalar components, add them up, and then find the vector. Find the magnitude and direction of the vector. Anyway, so that's it for this video. Bye for now.